Once again, welcome back. So in the previous session, we introduced the concept of maximum and minimum values of a function of several variables. So in this section, we are now going to give the necessary conditions, a function of two variables, x and y, to have a maximum or a minimum value, and then state the steps that you need to follow in order to determine such values. So conditions for extreme values. Conditions for extreme values of a function of two variables. So conditions for maximum values. So if f of x, f of a plus h, b plus k, minus f of ab remains the same, remain the same sign for all values. So both positive and negative. Of these changes, h and k, then the value of the function at AB is said to be extremum of the function f of xy at the point AB. So when the value, if the difference between the value of the function in the neighborhood minus the value of the function at the point AB remains the same sign for all values, both positive and negative, of these small changes in A value and B value, then the point or the value of the function at AB is said to be extremum. So extremum means it's either a maximum or a minimum value. So one, if the difference fa plus h, b plus k minus f ab always remains to be 0, then the value of the function at a, b is maximum. So that's the point number one, that when this difference is always negative, then the value of the function at AB is maximum. If difference is always positive, then f at AB is minimum. So then the necessary conditions for A of AB to be a maximum or a minimum is that the partial derivative of the function with respect to x and the partial derivative of the function with respect to y must be 0. So partial f, partial x equals to 0, partial f, partial y equals to 0. And then when you get the second derivatives, you let r to be second partial derivative of the function with respect to x. Let s to be the second partial derivative of f with respect to x, y, and t. So we can say this part 1, partial derivative, second partial derivative with respect to y. So from these second order partial derivatives, if RT minus S squared is greater than 0, then the function f of xy has a maximum or a minimum value at the point AB according to whether R is negative or R is positive. And as we shall see shortly, R, if this condition is satisfied and R is negative, then it's maximum, R positive is minimum. And then if RT minus S squared is less than 0, then there is no maximum nor minimum at the point AB. So this point is called a saddle point. So a case when this difference is negative, then no maximum or minimum, the point is called saddle point. And then lastly, if now this difference RT minus S squared is equals to 0, then the test is inconclusive. So this means that further investigation should be done. So then now, let's now give the step-by-step methods of solving the problem of finding the maximum and minimum values of a function. So steps. For finding extreme values. So when given a function of two variables, x and y, let's see how you need to work out, work through and determine whether we have maximum values, minimum values, or saddle points, or even neither. So step 1, differentiate the function f of x, y partially was a function of several variables to find out these four partial derivatives. So partial f, partial x, and then partial f, partial y, and then partial squared f, partial x squared, partial squared f, partial x, partial y, and partial squared f, partial y squared. So that's the first step. Differentiate f to have these 5 partial derivatives. So with respect to x, with respect to y, second derivative with respect to x, second derivative with respect to x and y, second derivative with respect to y. That's step 1. And then step 2, put partial f, partial x equals to 0, and partial f, partial y equals to 0, and solve this for x and y. And then let a be the value of x, y. So once you have gotten the first derivative with respect to x, first derivative with respect to y, equal to 0, and then you'll have those system of 2 equations in x and y. So solve them and let the value of x to be a, let the value of y to be b. So that's the point. That's step 2. Step 3, evaluate call R to be partial squared f, partial x squared, call S partial squared f, partial x, partial y, and call T partial squared f partial y squared for these values a, b. So once you have gotten the second partial derivative, then you replace the values of x, the value of x for a, y for b, and then determine the values of r, s, and t. Number 4. Now, if rt minus s squared is positive, and so there are two things. A, r is strictly less than 0, then the function f of xy has a maximum value at AB. So that's the first thing, that if you find out that the difference RT minus S squared is positive, and then you find that R is negative, then that tells you that that point AB is a maximum value. B, if R is positive as R greater than 0, then the function f of xy has a minimum value at AB. So if the second derivative with respect to x is positive, then the function has minimum value. Number 5, if you find that RT minus S squared is negative, then you conclude that the function f has no maximum nor minimum value at the point AB. That's the case where the difference is negative. And then number 6, if this difference RT minus S squared is exactly equals to 0, then the case is doubtful. And needs further investigation. So that means that we can't say it is either maximum or minimum or saddle. We can't say anything about the point being maximum, minimum, or a saddle point. So this needs further investigation. So these are the steps that you need to follow in order to determine whether the function f of xy has a maximum or a minimum or a saddle point or neither points. So just last thing, note that the point AB, the points AB, which just a point. Which are roots of partial f partial x equals to 0 and partial f partial y equals to 0 are called stationary points. Called stationary points. So briefly, let's go through the steps on how to find the maximum or minimum or simply extreme values of a function f of x or y. So the first thing, get the partial derivatives with respect to x, with respect to y. Then the second partial derivatives of the function with respect to x. And then the mixed second partial derivatives, that is with respect to x and with respect to y. And then the second derivative with respect to y. So that's the first step. And then the second step, to get the point itself, where we'll be testing whether it's a maximum, a minimum, or a saddle point, we set first derivative with respect to x to 0, first derivative with respect to y, 0. So this will give us an equation. This also will give us an equation. Then you solve these two simultaneous equations for x and y. Then we get the point AB, where A is the solution for x, B is the solution for y. And then step 3, you let second derivative of the function with respect to x to be r, second derivative of the function with this mixed partial derivatives to be s, and then the second derivative of the function with respect to y to be t. So these values of r, s, and t are the ones that are going to tell us whether AB is either maximum, a minimum, or a saddle point. So when you take r, you multiply by t, and then you subtract the square of s, if that value is greater than 0, then you either have a maximum or a minimum value. So the maximum is obtained when r is strictly less than 0, and then a minimum is obtained when r is strictly greater than 0. And then assuming that the difference between RT and S squared was negative, that's to mean RT minus S squared is less than 0, then the function has no maximum nor minimum value, but then it has what we call the saddle point. And then if you find that the difference RT and S squared is exactly equal to 0, then this test fails, and therefore you need to do further investigation to be able to determine the nature of that point AB. And then these values of A and B are called stationary points. So the next session now will give an example on how to find stationary points, or how to find maximum and minimum values of a point of a function using the steps we have listed in this class. So thank you.